Hey, very good morning, students. Let us look into our very next topic, lookup table. Okay, first let us understand what is this lookup table. Lookup table, in short, we call it as LUTs, L-U-T, LUTs. Okay, so this lookup table is nothing but is a combination of several static RAM cells in which we can store a truth table. In short, I can say it is a combination of SRAM cells in which you can store what? A truth table. So this is the definition of a lookup table. It is a combination of SRAM cells, static RAM cells, in which we can store the truth table. So using this lookup table, you can implement any combinational logic circuit. So let us try to implement a half adder, which is a combination logic circuit using this lookup table. Or in the exam, you may get a question like design a 2 input 1 output lookup table. So example for it can be an half adder. Can you see this is an half adder which has 2 inputs A and B. Output is a sum and carry. Now I need to design this using what? 2 input, 1 output lookup table. It means it has 2 inputs and only 1 output. So I am writing the truth table accordingly. I have a true input. Input is A and B, and I can use only 1 output lookup table. So S is my output. What is S? Sum. So 0 plus 0, 0, 0 plus 1, 1, 1 plus 0 is 1, 1 plus 1 is sum 0, carry 1. Clear? So I have written a truth table for sum. I have written the truth table for carry. So if I want to design this combinational circuit, I'm going to use 2 input, 1 output lookup table. So I'm going to design 2 lookup tables, 2 input, 1 output. One is for sum, other one is for carry. Now this is my circuit, this is my sum truth table, and this is my carry truth table. You know 1 plus 1 is sum is 0, carry is 1. Rest is all. Can you see 0 plus 0 is 0, 0 plus 1 is 1, there is no carry. That is why carry is 0. Now let us see this. 2 input lookup table has 4 memory cells. You all know if I have 2 inputs, there are 4 combinations. Each combination we need to treat it as a memory cell. Okay, 2 inputs means how many memory cells? 4 memory cells. Can you see? I am going to transform this truth table into a memory cell. Clear? Since I have 2 inputs, I need 4 cells. So static RAM cell 1, cell 2, cell 3, cell 4. What is that I am going to store in these cells? The output. What is the output? Sum 0, 1, 1, 0. So the output 0, 1, 1, 0 is stored inside the static RAM. So every box is a static RAM cell which can store only one bit, single bit. That is what I have stored here. I have stored a 0, 1, 1, 0, 0, 1, 1, 0. Okay, now can we define what is a lookup table? Lookup table is nothing but a combination of static RAM cells. These are all static RAM cells. So it is a combination of static RAM cells in which we store the truth table. Can you see? Output of this truth table is stored in the static RAM cells. Now the logic inputs are connected to address line. I said it is 2 input, 1 output. The logic inputs A and B are connected to what? The address lines. Okay, A and B are connected to address lines. The logic output, what is logic output here? Logic output is sum. The logic output is connected to the memory elements. Can you see? These are all memory elements. Logic output is connected to the memory elements. A and B is connected to the address. Done. Now, can you see if I want, if my address A and B is 0, 0, if my address A and B is 0, 0, the content stored in that memory location will be 0, that will come out as an output. If my address is 1 and 1, the content stored in memory location 1, 1, the content will come as the output. So this is what called as lookup table configuration. Now let us see it for a carry. So carry, can you see? A and B are the inputs. The inputs are connected to what? Address. A address and B address. So C is the output. Every single output is stored in a static RAM cell. So 1, 2, 3, 4. I'm using 4 static RAM cells in which I'm storing the output 0, 0, 0, 1. Okay, and that C logic input or logic output C is connected to the memory element. Now see, if my input is 1 and 1, I need to go to the address 1 and 1. This is the address 1 and 1. What is the content stored in that address? 1. That will come as the output. So this is 2 input, 1 output, LUT. What is an LUT? LUT is a combination of memory cells. These are all static RAM cells, SRAM cells, which can store 1 bit information. In this case, always we should store the truth table output in the memory cells. Input of truth table should be connected to the address lines. Clear? Now, by chance, alternative way is, can you see, this is my sum lookup table, 2 input 1 output. This is my carry lookup table, 2 input 1 output. We can also merge it like this, because if I give same address 0, 0, what happens? The sum output will be 0, the carry output will be 0. So we can also merge it like this in the construction. So this is very widely used or commonly used. This is possible only if the address has, or the input, the address is same for both. Can you see, if it is 0, 0, it means we are going for 0. If it is 1, 1, we are going for 1, 1. This is possible only when the address remains same. So this is an example for 2 input, 2 output LUTs. So mostly we are using 2 input, this kind of LUTs, where if we have a similar address, we can go for this kind of setup. So what is a lookup table? In short, lookup table is nothing but combination of static RAM cells which is used to store what? Truth table. Thank you. This is about the lookup table.